Hello everyone, I'm Paul and today we're solving problem 679, 24 game. This is hard, so we will go step by step. We're given 4 cards with numbers in the range from 1 to 9. And we need to use these 4 operations to get the number 24. And we need to return true if we can do this or false otherwise. So let's say we're given these cards. Our approach will be to try every possible combination, every possible scenario. And I think the trick here is to think in small terms. So let's say we have one scenario in which we take these 2 cards, 4 and 1. Now for these 2 cards we have 4 operations to do. We can do 4 plus 1, 4 minus 1, 4 times 1, and 4 divided by 1. And you could also think of doing 1 plus 4, for example, but this doesn't make sense because the result for this is equal to the result for this. Similarly, 4 times 1 is the same as 1 times 4, so this also doesn't make sense. Now, 4 minus 1 is not the same as 1 minus 4, so we can add this scenario in which we do this operation. And similarly, here 4 divided by 1 is not the same as 1 divided by 4. So here we have another possible scenario. So here we have 6 possible different scenarios for every combination of cards. So the approach will be the following. Let's say we are here in this scenario. We did 4 plus 1 and the result is 5. We will put back in the deck the result for this. So now we are replacing these 2 numbers with a 5 and we have 8 and 7. Remember, this is only for this scenario. And here we will repeat the same process. We will try every different combination of cards and we will apply these 6 operations. So for example, let's say we take these 2 numbers, we do 5 plus 8, and all of these operations, and each of these operations is a different branch, is a different scenario. So let's say we are here in this scenario, 5 plus 8 is 13, so we will replace these 2 numbers with 13. So this will be the new deck in this case. So here we do exactly the same. We take these 2 cards and we apply these 6 operations. And for the first scenario we have 13 plus 7, which is 20, so we replace these 2 numbers with 20. So the new deck after doing this has only one number, which is 20. And when we reach this point, meaning the length of the deck is 1, here we have a base case, meaning we have reached a leaf here. So if this number is 24, we just return true. And if it's not 24, we return false. So we will try every possible branch in this tree, and if at any time we find 24 for any leaf, we just return true, else we return false. Remember, here we have roughly 4 factorial times 6 operations to the power of 4 cards. And this is the amount of nodes. And given that this is constant, meaning we know that the amount of cards is always 4, we could say that this has roughly big O of 1 time and space complexity. It's a big constant number, but it's still constant. And remember, this is only one possible branch. When we take 4 and 1, we can do this operation or this operation or this one or this one or this or this. And for example, if we go with this branch, next we have all of these scenarios. And for example, here in the start, instead of taking 4 and 1, we can take 4 and 8 or 4 and 7 and so on. So remember, we have all of these nodes. So this is it for the approach. I know this might seem a little bit confusing, but I recommend you to take this step by step and try to visualize the size of this tree. Here we have 4 cards, and although time complexity is big O of 1, we have many different scenarios. So now let's go with the code and hopefully you will get the idea. First, we need to create our DFS function, and this will take an array nums. This is the deck of cards. And first we have our base case. So if the length of nums is 1, we need to return. And more specifically, we are returning the result true or false. So if nums 0 is equal to 24, we return true, else we return false. But the problem is that this number might not be an integer. This might be 23 point something or 24 point something. So we can use a Python function here, which is close. And if nums 0 is close to 24, this returns true, else false. So now we can say n is the length of nums. And now we can try every pair in the current array nums. So we say for I in range n and for j in range n. And first we say if I is different from j, we can take our base array, meaning every card except for the 2 current cards. We'll call this base. And this is an array, and here we have nums k for k in range n if k is different from I and k is different from j. So we are filtering I and j cards. So now we have 6 different scenarios here. Remember the drawing a few minutes ago. First, we can say we have the scenario in which we take the current base and the result for nums I plus nums j. So we say if DFS with base plus an array, we are using an array here to be able to concatenate this with base. And this array will contain the result of nums I plus nums j. So if this returns true, meaning if we ever reach a point in which we only have one value in nums and that value is roughly 24, we just return true. And now we need to add every other scenario, so we can copy this 2, 3, 4, 5, 6, and next we have minus times divided, and here nums j could be 0. So here we need to add an if statement. If nums j is different from 0 and this will return true. And here we have base plus, this is nums j minus nums I, and here we have nums j divided nums I, and this could also be 0. So we say if nums I is different from 0 and this will return true. And finally, after all of this, if we never return true, we just return false. So we can call DFS with cards now. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.